Well, hello physics students, and welcome to this video lecture that's going to introduce you to angle-launched or non-horizontally launched projectiles. So far, what we've been working with are horizontally launched projectiles. So we've been working with projectiles that follow kind of this half parabolic path, okay? But now with angle-launched projectiles, we're going to be dealing with projectiles that follow this full parabolic path. Now, with a parabola, what we can see here is that we have symmetry across this vertical line that I drew in here. And that means some pretty significant things for us. Namely that if we know what the velocity is right here, okay, this is some velocity v, well, we're going to have that same velocity over here on the other side, just in the opposite direction, okay? And that goes for all of these. So I have some velocity here, I have the same velocity then over here. Okay, so we have an incredible amount of symmetry across this vertical line here. There's also some other really important things that we need to know in terms of angle-launched projectiles. And I'm going to circle this point right here. This is the kind of the peak, I guess we'll say the peak of this projectile's trajectory. And we know quite a few things at this peak. First, well, if this is the peak, then delta y here is delta y max. That means that this is the maximum height that that projectile travels. We also know that delta x at this point is 1/2 of the total delta x, okay? So if this is our delta x here, this whole thing is delta x, well, right here at this point, that's 1/2 of delta x. We also know that time at this point is time 1/2, okay? So whatever the time is at this point right here, that's 1/2 of the total time it takes for that projectile to travel. One last thing that we know at that point is that Vy is equal to 0 meters per second. We know that delta y, this is the maximum point, this is the max height that it reaches. So at that maximum height, that vertical velocity, or that Vy, is equal to 0 meters per second. So really, if we take a look at this, once we get to that halfway point, this is basically just a horizontally launched projectile at this point, okay? And then we could say, going from here back down this way, that's also a horizontally launched projectile. And that's going to be a huge tool for us when we solve angle-launched projectile problems. If we can split this up and simplify it down to a horizontally launched projectile problem, that's going to make our lives a lot easier. One other really important thing that we need to know with angle-launched projectiles is that we have components of our initial velocity now. When we were dealing with horizontally launched projectiles, all we had was an initial horizontal velocity. But now, I'll just give you some initial velocity, okay? And we know that that projectile is being shot at some angle theta. So what we need to do, because again, we need to work in our x and y directions, we're going to have to split this guy up right here into its x and y components, okay? So we're not just going to be dealing with v initial, we're going to be dealing with v initial x, and we're going to be dealing with v initial y. Well, how do we find those? How do we figure those out? Well, we know that that thing's being shot at some angle theta. Take a look here. We have a triangle, so we can just use trig to figure this out. So I'm going to kind of zoom out here, and let's just take a look at this in a little more detail. So I have v initial. I have my x component of v initial, so v initial x. I have my y component of v initial y. And I know that that v initial is at some angle theta. So we just need to use trig here again, because you know that this is a right angle, or right triangle. We just need to use trig to figure out what those components are. So If we want to figure out what v initial y is, well, this is the opposite side of that angle. So we're just going to be using our sine function. So v initial in the y is going to equal v initial times the sine of theta. If we want to find v initial x, well, this is the adjacent side of that angle, so it's just going to be v initial times cosine of theta. Okay, so big things here. We're going to try and split these problems up. When we work with angle-launched projectiles, we're going to try and split them up. Knowing all this information at this highest point, or at the peak of that projectile's trajectory, knowing all this stuff is going to help us out a ton. And then another big key here is that we have to split this initial velocity up because we want to work in the x and the y direction. We cannot just use v initial. We need those initial components of that velocity. So, brief introduction, giving you some conceptual things to think about, but also some mathematical things down here, and we're going to keep applying this stuff in the coming days. So, take care, physics students.